Dear students, welcome back. This is Dr. Buju Vaisdevan, and this is the last video for the course Calculus 2, mm, in which we are going to discuss week 15 chapters 9.7 Maclaurin and Taylor polynomials, Maclaurin and Taylor series. We don't need to discuss convergence of the Taylor series because it's not included in the final exam. Okay, fine. Actually, I'm not going to see any introduction right now. I just directly solve some problems of Maclaurin Taylor polynomials, Maclaurin Taylor series. Of course, the statement of the theorem 9.72. A function f can be differentiated n times at a point 0, whatever the function, isn't it? For example, if you write f of x is equal to x square, you can find f dash of x 2x f double dash of x 2. So if it is differentiated n times, here it is 2 times. At 0, we can find f dash of x, f dash of double dash at 0. Then we define the nth Maclaurin polynomial to be a polynomial of nth degree. P stands for polynomial of degree n. The function value at 0, first derivative at 0, second derivative at 0, third derivative. So find n derivatives and substitute the x value, and then the order. See, it will be like a constant 1 plus constant 1, 2x, constant, this is constant 0, constant 1, constant 2x square, constant 3x cube, this way. And this constant is nothing but here 0 factorial, 1 factorial, 2 factorial, 3 factorial, 4 factorial, up to n factorial. So in this order we should write. Here the condition will be Pn of x is f of x, and p of x is equal to f of x. P1 of x, p dash of x is equal to p n of x is equal to f of x. First derivation of p is equal to first derivation of x. Second derivation of p is equal to second derivation of x. Under this condition, we extend actually this one. This is actually extend approximation, kind of approximation of the curve at the particular point. If the point is non-zero, then the Maclaurin polynomial is considered Taylor polynomial. So Taylor polynomial is the major thing that we have to discuss, and Maclaurin is a special case of Taylor series. Taylor series is for any point x is equal to x0. When the point x0 is 0, then the Taylor series is called Maclaurin series. So how do you expect to write Taylor series for the same function where x is non-zero? This is not Taylor series, actually polynomial of nth degree. We stop at nth term. We will not extend to infinity degree here. It's an infinity. F of 0 is f of x0, any point. X0 is any point. Instead of x is equal to x0, or you can call it a x0. First derivative of f of x at x0, and the same x minus x0 divided by, I erase this page and then write it clearly. So how do you write Taylor polynomial for Taylor polynomial of degree n? P n of x for Taylor polynomial can be written as f of x0. This x0 is not 0 for Taylor's polynomial, right? Second, f dash of x0, x minus x0 divided by 1 factorial. Actually here it is 0 factorial. 0 factorial is also 1. Third term, can you guess? F double dash of x0, x minus x0 divided by 2 factorial. It goes on. F triple dash of third derivation at the point x0, x minus, here x minus x0 whole square, here x minus x0 whole cube divided by 3 factorial. It's going on. So when x0 is 0, you get this one. This is, so you remember Maclaurin polynomial or Maclaurin series, whatever it is, a special case of Taylor polynomial and Taylor series as well. So some graphical presentation of this approximation we are going. This is the formula for Taylor polynomial. See that we have seen here the previous slide. Let's straight away go and solve some problems. Find the Maclaurin polynomials of order 0, 1, 2. Order 0 means there is no derivation, isn't it? The function itself. Okay. We will find the Maclaurin polynomials of orders 0, 1, 2, 3, 4, and then find the nth Maclaurin polynomial using the sigma notation. We will use finally the sigma notation. This is actually x into e raised to x. Okay, fine. What is the first one? First one is e raised to minus x. So let us start with the problem number 7, e raised to minus x. Given function f of x is e raised to minus x. So from the polynomial, what we understand is polynomial of, let's write the formula for the nth polynomial. What is it? Nth polynomial of x is f of x 0 nth Maclaurin polynomial, isn't it? So we need to substitute the value x is 0. So x is 0 at, so obviously everything at all the three problems for at x is equal to 0. So when it is Maclaurin polynomial, it should be understood. So what is it? X is 0, we can write okay, f of 0 plus f dash of 0 x divided by 1 factorial f double dash of 0 x square divided by 2 factorial f triple dash of 0 x power, this is x square, this is x cube divided by 3 factorial, and the nth term f nth derivative of x is 0 at x power n divided by n factorial. This is it. When n is 0, what do you write? 0 factorial and no derivation, no x. So p0 of x is f of x. And what is p1 of x? p1 of x is the first two terms. p2 of x will be first three terms. In this way we are going to find up to fourth order, right? Is it clear? So p1 of x is f of 0. This is f of 0. F of 0 plus f dash of 0 into x over 1 factorial. So we have to find the derivatives first. F of x is given here. Find f dash of x, which is e raised to minus x and minus, isn't it? So what is f dash of 0? And e raised to 0, it will be negative 1. So what is second derivation of the function? Again, e raised to minus with positive. So second derivation at 0, it is positive 1. This way, try third derivative. I'm writing here. Third derivative of the function x is negative e power x. So you get third derivative at 0 is negative 1. Similarly, you will find the fourth derivation at 0 is positive 1. Fifth, we don't want fifth derivation, isn't it? We have to find up to fourth order. Okay. Now what is p0 of x? F of 0. F of 0 in the original function, if you apply f of 0 is 1. What is Maclaurin polynomial of order 1? p1 of x is f of 0 is 1 plus f dash of 0 is negative 1 x over 1 factorial is 1 factorial. So this is 1 minus x. Okay, and then what is p2 of x? First three terms, f dash of 0 is 1, f of 0 is 1, f dash minus f dash of 0 is minus 1. So 1 minus x should be written p1 of x. The third term is second derivative of x at 0. Second derivative of this one is positive 1 x square divided by 2 factorial. 2 factorial is 2. So the answer is 1 minus x plus x square over 2. Can write this one as x 1 minus x over 1 factorial, x square over 2 factorial. You can continue the pattern, isn't it? So can you try the third order 3 p3 of x. What is p3 of x? 1 minus x over 1 factorial, x square over 2 factorial, plus or minus is minus x cube over 3 factorial. For fourth order, 1 minus x over 1 factorial plus x square over 2 factorial minus x cube over 3 factorial plus x raised to 4 over 4 factorial. So nth term Pn of x is the same. 1 minus x 1 factorial can be extended up to nth term. So it is x power n divided by n factorial and minus 1 to the power n or n plus 1. What is the first number is 0, n is equal to 1, it is positive, so n plus 1 is good. Negative n plus 1. So how to write using sigma notation, which is summation n from 1 k from 1 to n, k from 1 to n minus 1 to the power k plus 1 x power n divided by n factorial. This way we should proceed. Actually this is k plus 1 and x power k divided by k factorial. This is using sigma notation. Now let's try this. Actually for the problem e power minus x we have done, right? Now we are going to do the same work for x. ln 1 plus x, ln 1 plus x. What do you have? This is your f of x. First find 4 derivatives. F of x, okay, f dash of x is 1 over 1 plus x, and at f dash of 0 is 1. F double dash of x, f double dash of x minus 1 over 1 plus x, 1 plus x whole square, and when you substitute 0, that is Maclaurin 0, f double dash of 0 is, this term will be 0, that's all, negative 1. F third derivation of x is 2 over 1 plus x whole cube. When third derivation at 0 will give you, this will be 0, 1, 2. And fourth derivation I am writing here. Fourth derivation of x is minus 6 over 1 plus x to the power 4. And when you substitute x, fourth derivation x is 0, minus 6 will be the answer. And we want only up to fourth derivation, because the formula for fourth order Pn of x, p fourth order of x, isn't it? A polynomial of degree 4 will be f of 0 plus f dash of 0 into x over 1 factorial, f double dash of 0 x square over 2 factorial plus f triple dash of 0 x cube by 3 factorial, f fourth derivation of 0 and x power 4 by 4 factorial. These are the 5 terms found for. I write the fourth order term, you will then write all other terms. What is p4 of x? First f of 0, in the f of x is given here. What is f of 0? ln 1, which is 0. So first term is 0. Second term, f dash of x is positive 1 into x divided by 1 factorial. Third term, second derivative will be negative 1 x square divided by 2 factorial. third term actually second derivation is what? Second derivation is negative 1, so negative 1. Third derivation is 2 into x cubed divided by 3 factorial. Fourth derivation is negative 6, so this is negative 6x power 4 divided by 4 factorial. So we can say p0, what is from this one you can write p0 of x is 0, p1 of x is x, p2 of x is x minus x square by 2, p3 of x is x minus x square by 2 plus 2 divided by 3 factorial. What is it? 3 factorial is 1 into 2 into 3. So 2 can be cancelled, it will be 1 by 3, isn't it? So this is, that term is x cubed by 3 with a negative sign. So we can write all the 4 terms. Now nth term I write here, nth polynomial. We can extend the same way for n terms, and nth term, you see, it will be cancelling. See, like what is the nth polynomial of this one? You will get x plus x square x minus x square over 2 plus x cube over 3 minus x raised to 4 over 4. It will go like x raised to 5 positive over 5 negative x power 6 over 6. It's going, so it will be, nth term will be x power, first term is 1, second term 2, third, so x power n is the degree. There will be n the denominator, and negative 1 to the power n plus 1. That's it. So we can write in summation notation k from 1 to n, negative 1 to the power k plus 1 x power k divided by k. That's it. We can try this for x into e power x. And I am going to solve one problem from Taylor series, Taylor polynomial. Find the first 4 distinct Taylor polynomials about x equal to x0. X equal to 0 is pi. We are not using any graphing utility, just writing this series, right? So after this Taylor polynomial, we will go to Taylor and we will take one example from Taylor series and one example from Maclaurin series. This is nth 4 distinct Taylor polynomials, isn't it? That's it. For first 4 orders we will do it. Okay, the function given is f of x at x. So first derivative is sin x, and first derivative at pi, not 0 here. x0 is not 0, pi. If it is 0, then it is called Maclaurin polynomial. That's it. That's the only difference. Sin pi is 0. Second derivation of x is cosine x. So second derivation of pi is minus 1. Third derivation of x is minus sin x. So third derivation at pi will be 0. Fourth derivation of x. We need only 4 polynomials, isn't it? Let's try first 4 distinct polynomials. Let's try. Fourth derivation will be minus cosine x. So what do you get? Fourth derivation at pi will be 1. So for even derivation numbers, the derivation is even order, then it is either negative 1 or positive 1. For all odd orders, it will be zeros, isn't it? And you should recall the formula here. I'm writing the formula for Pn of x, Taylor polynomial of degree n, isn't it? This is f of pi is our point, f prime of pi, first derivation of f pi divided by 1 factorial x minus pi, second derivation of second derivation of pi divided by 2 factorial x minus pi whole square. In this fashion it is going up to nth degree, isn't it? F nth derivation of pi at divided by n factorial into x minus pi to the power n. So that is the formula, isn't it? Now when we substitute first, when you take the first point, what is p0 of x? F of pi. What is f of pi from the given problem? F of pi is cosine pi is -1. So -1 first term, p1 of x first term is -1, second term f derivation of pi from here 0. So again p1 of x is 0. So you are getting same polynomial. See, we are asked to find 4 distinct polynomials. That's the highlight. So these two polynomials are same. So they are repeating, so not distinct. So p0, p1 are same. Let's try p2 of x. What is it? p0, p1, -1, isn't it? -1 p0, -1 p1, and then for p2 third term second derivative of pi is -1 x minus pi whole square divided by 2 factorial. So what do you get? -1. So we will write this one -2 negative x minus pi whole square divided by 2, because second derivation is negative. So third one, you can try third and the fourth. I think I am leaving it to you. I'm going for the next problem. You can try third. First 3 has been written here. This is actually p1, p2 for degree 2, p3 up to degree 3. This one plus the last third derivative term. Third derivative term is 0, so it will repeat. So we don't need to. So p3 of x will repeat as what p2 of x. So p4 of x should be found, isn't it? p4 of x will be of degree 4. Fourth derivative is 1. So I guess it is p4 of x, p3 of x, which is same, -2 minus x minus pi whole square divided by 2, and okay, actually we have found these two are repeating, so we are not adding this p1 here, so it will be -1, -1 and actually I was looking for the mistake why I have committed here. It is actually cosine, derivation of cosine is negative sign. Actually I have forgotten this negative here, that led to the mistake here. Therefore this 0, this will be negative cosine x, this will be +1. this will be 0 and this will be negative 1 here. Therefore, p0 of is negative 1. p1 of x is p0 plus second term is 0. p0 is negative 1, so it's negative 1 again here. So p2 of x is p1 plus then third term will give you this positive 1 by 2. For p1 is negative 1, so negative 1 plus this term, negative 1 plus this term, and p3 of x, when you find it will be p2 of x plus the next term. This is up to second degree, so third derivation is 0, so there is 0. Second p3 is p2. Now what is p4? p3 is p2, so what is p4? That's the question. p4 is p3 plus the next derivation. So these are same. p0 and p1 same. So p0 is a distinct one, p2 is a distinct one. Now we are going to find we have to find two more, p4, check p5, p6 in this way. Right, let me type p4. What is p4? p4 of x, which is p3 of x plus the formula p3 of x. Can you recall what is p3 of x? Which is p2 minus 1 plus x minus pi whole square divided by 2, isn't it? And third derivation is 0. Here it should have been fourth derivation. Fourth derivation of x. Fourth derivation of x is cosine x, and fourth derivation at pi you get negative 1. So here it is negative 1 into x minus pi to the power 4 divided by 4 factorial. p3, you can rewrite p3 minus 1 plus x minus pi whole square divided by 2 factorial is 2. Here it is minus x minus pi to the power 4 divided by 4 factorial, which is multiply up to 4 factorial. What is 4 factorial? 1 2 3 into 4 60 24. So this can be written as 24. And obviously if you find p5, it will be the second derivation, next derivation will be 0, it will be p4. Okay, so if you find p6, it will be p5. p6 it will be p5 plus next time p5 is nothing but p4, so you can repeat here p4 plus the sixth derivative will be negative 1 or positive 1. Fourth derivation negative 1, 4. This is positive 1 x minus pi to the power 6 divided by 6 factorial. These are the 4 distinct polynomials. You can repeat p4 here, right? 6 factorial you can expand it to 7. 6 factorial, if you expand, you will get 720. That's the end of this problem. And I'll solve one problem for Maclaurin series, and I'll give YouTube videos for Taylor series. Let's take, there are many problems, 3 problems, but it's not clear in the PowerPoint, right? Okay. Maclaurin series, this is nothing but e power minus x, this alone. These two problems have been seen in the Maclaurin polynomial case. Just follow them. For n series means you should write a function f of x as infinitely many times, isn't it? So this is f of 0 plus f dash of 0 into x divided by 1 factorial. The same way it goes on infinitely. We will not stop at the degree, infinitely larger. That is Maclaurin series. If it is non-zero, then f of x, the Taylor series will come as f of x0 plus f dash of x0 into x minus x0 divided by 1 factorial. Here second derivation at x0, x minus x0 whole square divided by 2 factorial. This way it will go to infinitely larger terms, that is Taylor series, right? Now this term is what? X times sine x. Now we will solve this problem number 9 in Maclaurin series. So I'm solving this one, problem number 9, which is x into sine x. So I'm writing the Maclaurin series here, which is f of x, a function is expressed as a series, function is x sine x, f of 0 plus f dash of 0 times x over 1 factorial, f double dash of 0 x over 2 factorial, just to find 3 or 4 times, f third derivation of x at over 3 factorial times x. This x square, this x cube is going on. You need to catch the pattern to write the nth term until you can find 4 or 5 times to get the pattern. That's it. Now f of x is given here, and the point is x0 is 0 because it is Maclaurin series. Okay. This is f of x. Find the derivative of f of x. F dash of x. Use product rule. When you keep sin x and differentiate x, it will be 1. When you keep x and differentiate sin, it will be cosine. First derivation is done. What is the value of function at 0? When sin is x1 is 0, this is 0, this is 0, 0. Second derivative of x from here. Derivation of sin is cosine, and then use the product rule here. Keep x, differentiate cosine, you will get negative sin x, and keep cosine x, differentiate x, you will get cosine x. So second derivation at 0 will get you what? This is 1, this is 0, that is 1, answer is 2. So third derivation at from here. Differentiate this one, cosine, you get negative sine. Differentiate this one also, you get negative sine. Now use product rule for this one. Minus is outside. Keep sin x, differentiate x, it will be 1. Plus keeps x, differentiate sine, it will be getting cosine x. So when x is 0, this sine 0, cosine 0, sine 0, x will be 0, all 0. So finally you will get f triple dash of 0 is 0. See, for every odd derivative you are getting 0. For even derivative you are getting number. So let's try 2 more terms to understand the pattern. Fourth derivative. You try, I am writing here. Fourth derivative will give you, fourth derivative of x will give you negative 4 at 0. Fifth derivative of function at 0 will be 0. Sixth derivative at 0 will be minus 6 or positive 6, positive 6, right? And seventh derivative will be 0. And eighth derivative, can you guess now? At 0 it will be negative 8. So we will get up to 8 derivatives. Now we can write this series. I'm writing here all the elements. F of x. So x sin x is equal to f of x is x sin x. F of 0, first term is 0. F of 0 is 0, first term is 0. First derivative is 0, so first second term is also 0, isn't it? Third derivative, second derivative here. What is it? Second derivative is 2. So we start from this 2 x square divided by 2 factorial. Third derivative is 0. Fourth derivative is x power 4 negative 4 divided by 4 factorial. Fifth derivative is 0. Sixth derivative is 6 and x power 6 divided by 6 factorial. Seventh derivative is 0 and eighth derivative is negative 8. x power 8 divided by 8 factorial. It's going on this way, isn't it? So what do you understand from this? You start from this number, and for every odd degree it is 0. Even degree you will get first negative and first positive and second negative alternative sign, isn't it? So we repeat this series again. What do you get? The series 2x square over 2 factorial minus 4x power 4 over 4 factorial plus 6x power 6 over 6 factorial minus 8 x power 8 over 8 factorial. It's going, isn't it? So x sin x, isn't it? That's the function x sin x. So when you cancel 2 with the 2 factorial, you will get 1 here. So x square divided by 1 minus x power 4 divided by 3 factorial. 4, see, 4 divided by 4 factorial. 1 into 2 into 3 into 4. The last time will be cancelled. So the first 3 will be 3 factorial. That's here. So 6 over 6 factorial will be x power 6 divided by 5 factorial minus 8 power x power 8 over 7 factorial. It's going in this way, isn't it? Now we have to write general form for infinite series. This is series infinitely larger, so infinitely going on. Summation n is from 1 to infinity is going on. See, x in the power of x, there's an even number, so x power 2n. In the denominator you get odd numbers, factorial. So odd numbers 2n minus 1 is the suitable formula for odd number in this case, because n equal to 1 it will be 2 minus 1, n equal to 2 4 minus 1 is 3, n is equal to 3 6 minus 1 5. So it's going 2n minus 1 factorial in the denominator and alternative sign. So you start with the second term, so you will write minus 1 to the power n plus 1. This is the formula for x sin x, x sin Maclaurin series expansion of this function. See, you can use Maclaurin series expansion to find the expansion of e power x, sin x, cosine x, and ln 1 plus x. That will give, so all this Maclaurin expansion of this function will give you the original expansion of these functions, the series representation of the functions. You can try all these functions. And for Taylor series, you want me to discuss one problem, or will you take up your own problem? Let me check how many problems have been given for. There are some problems. This is e power x at x equal to 1. So the same concept you have to repeat, but x0 is not 0. That is it. So you try yourself for Taylor series. I'll give some YouTube videos for this one. Thank you very much.